Well, hello, everyone. It is 3 o'clock, so it's time to get the show started. So I'm Glenn Ahrens, your OSU Extension Forester for Clackamas, Marion, and Hood River counties. And it's my pleasure to be your host and your not your presenter, but your host for today's Tree School online webinar. Tree School Online is a production of the OSU Forestry and Natural Resources Extension Program and the Partnership for Forestry Education. We want to give special recognition to the Oregon Forest Resources Institute for leading the project, and to the U.S. Forest Service and the Oregon Department of Forestry, who have helped us fund this with a grant for our expenses. This is the last Tree School Online webinar for this season of 2022. Please visit the Tree School Online page and the knowyourforest.org website for updates in the future, and also to find past classes and references. Note that we're going to be working on plans for in-person tree school classes in the field, and also hopefully back at the community college for 2023. So stay tuned for news on that. So I have some housekeeping details to discuss. The Zoom toolbar should be located at the bottom of your screen. And if you don't see it, you can scroll your cursor over the area. It should pop up. On some hardware, such as iPads, the Zoom toolbar is on top of the display, and you can access various features of Zoom from that toolbar. Your audio is muted as a participant unless we unmute you, and video is not available for participants. We'd like you to put your questions in the Q&A box, write them in there, and we'll be monitoring that throughout the webinar. We're asking, again, that all the questions be written in the Q&A box, since we're not able to take spoken questions. And then the chat function is to be used if you're having problems. You want to talk to our co-host in the background, but please don't post your questions for the presenter in chat. Resources can be found on the Tree School Online class guide. That'll be on the OSU Extension side. You can also get it through the Tree School Online Know Your Forest site. And my co-host today, Dan Stark, will be putting links in the chat periodically to remind you where you can go to get things. And then you can click on the webinar description and look for the webinar you're interested in. And above each description, there'll be links to more of the resources that our instructors provide. If you want professional logger credits from the Associated Oregon Loggers, that's something that we offer for these, and there's a link for that as well that will be posted in the chat. The webinars are being recorded. They'll be archived as YouTube videos, so you can go back to find them later or tell your friends. There's a lot of great resources in our library. We've got something like 55 classes now in the library, so there's a lot of great stuff online in the archives. We use polls during the webinar at the beginning and also an evaluation poll at the end, and they should pop up on your screen and you have a chance to answer the questions, and then we'll close the poll and we'll see what we've learned from the poll. So with that, I'd like to introduce our speaker today, Dave Bugni. So it's really my pleasure to feature Dave on this Healthy Streams Tree School webinar. Dave is a retired civil and structural engineer. He's a member of the board of directors for the Clackamas County Farm Forestry Association and also for the Clackamas River Basin Watershed Council. The Bugni family are small woodland owners on 83 acres in rural Estacada, and they were the 2020 Clackamas County Woodland Farmers of the Year. And also in 2019, they received a joint Oregon Department of Forestry and Oregon Department of Fish and Wildlife Steward Award for Forestlands for Northwest Oregon region. Dave has managed and placed over 100 logs, 150 tons of gravels, 200 boulders within the stream on their property, and designed riverine and coastal structures along the West Coast for decades. And he holds an MS degree in structural engineering and structural mechanics from the University of California, Berkeley, and a BS degree in civil engineering from Oregon State University. So with that, just like to turn it over to you briefly, Dave, to introduce your program, and then we'll have the initial poll after that before we really get started. Go ahead, Dave.
Okay, thanks, Glenn. Can everybody hear me just fine?
I can hear you.
Okay. So today, for some reason, the slide isn't advancing.
You have to wake it up, I think, if you just click on the PowerPoint on your computer.
There we go. Here we
Yeah, I see it now.
So with that, there's our title. There's our title slide. Does that one look good?
Yes.
Okay. So do you want to launch into the first poll now, or?
Yeah, if you don't have anything else to say, we'll just launch into the first poll, and then of course you'll have the rest of the show. So with that, I will start a poll. You should see that pop up on your screen, starting with where you're from, and then whether or not you're a woodland owner or a natural resource professional or other, and if you own forest land. And then Dave has a couple of questions at the end about whether your property has a fish-bearing stream and if you're involved in fish enhancement projects. So I'll give you a little time to go ahead and see that. I don't see any responses yet. Hopefully you're seeing the poll. There we go, almost 100%. All right, going once. I'll go ahead and call it, and everybody's participated. So I'm going to end the poll and I'll share the results. And just for your benefit, Dave, we'll see where folks are from. So we got a good spread. Willamette Valley is only about 30%, coastal Oregon, 14%, one from Southwest Oregon, Central Oregon, and also Washington State. And actually the majority of our students are from elsewhere in the USA. So this is great. Welcome to Tree School Online. And I'll stop sharing. Oh, wait, I want to see the other answers, sorry. As far as the makeup, woodland owners are about 60%, and some natural resource professionals and also other. But the questions that Dave wants to hear about, woodland owners about half here, but of the folks that do own land, how many have a fish-bearing stream? And so we've got about half of our audience has a fish-bearing stream. And then others say no, or it's not applicable. And then, are you involved in fish habitat enhancement projects? And here we have about a little more than a third that said yes. And then not yet, but want to be is actually the other third, and about 30% said no. So that tells you something about our audience, Dave. And with that, now I can turn it over to you.
Okay. Well, thanks, Glenn, again. And that's interesting results. So I'll adjust my presentation a little bit accordingly. So when Glenn asked me to present on this topic, he suggested I describe more than just the nuts and bolts of the type of work that we've been involved in. So he proposed that I dive into how one is driven to do these things and my experiences that led up to these efforts. And this is particularly relevant for small woodland owners like many of us here today. So given our love of the land and that we want to do as much as we can to take good care of it. So if you'll bear with me for the first 5 minutes or so, prior to really delving into the meat of our topic, I'd like to explain a little bit of my background and how that spurred my interest in these types of very rewarding projects. And it may even overlap with some of your interests as well. So, darn thing, there we go. So on my dad's side of the family, our ties to forests go back over 100 years. So our grandfather, Anton, or Tony Bugni on the left, started his forest products business in about 1904. And it's pictured here a few years later by a large eastern white pine just before the crew cut it down in northern Wisconsin, where my dad's family grew up. And the photo in the upper right features Tony in the foreground in the hat, still working at age 81. And along with my uncle Anthony and my older brother Larry, both on the log deck. To my knowledge, this is the only photo that we have in our family that shows 3 generations of our family simultaneously working in the woods up in northern Wisconsin. So then the photo in the lower right shows my family by one of our Douglas firs on our place. And over 50 years separates each of these photos. And our family's approach to forest management has evolved substantially during that period as folks have learned more. So I've also loved to fish, and if it had gills, I went for it, as some of you know. And here, a small northern pike for a small kid back many moons ago. And I continued to fish avidly up until the photo at the right was taken along the Rogue River, in this case for salmon. And then I focused on other activities, but my wife, Marianne is to the left of me with her catch of the day.
Hey,
And then
David,
by high school, what's that?
your audio is starting to slow down, so you might try turning your video off and see if that helps audio.
I will do that. So, okay, so by high school, I became more interested in the scientific side of things, particularly water quality, as we lived near a river that flowed through the heart of Milwaukee's Industrial Valley, portions of which were quite polluted. So this year-long analysis that we did of 17 chemical pollutants, which I performed with a friend of mine and pictured on the left with our chemistry teacher, spurred additional work by the Wisconsin Department of Natural Resources at that time, as such analyses had not been done before this river, on this river, and our results were quite concerning. So while I didn't pursue a career in chemistry, I continued to be fascinated by water quality and perform my own studies of the surface waters around where we live today. So in the middle photo, I'm using a multi-probe meter, which in a matter of seconds provides results that took us many hours in the lab to do back in 1977. And more recently, in the lower right photo, I'm leading the largest water temperature study of the Clackamas River Basin, which will continue through next year and now also involve Portland State University. There we go. And I came out to Oregon to pursue my course of study in forest science at Oregon State. I chose Oregon because of two books that my mom, who's a librarian, suggested I read. And I thought she picked some really good books. I mean, these books solidified my desire to come on out here. And most Oregonians should recognize the titles. On the left, Ray Atkinson's Oregon photo book, and Ken Kesey's Sometimes a Great Notion. And that's all it took for me. After I got into those books, I was hooked. And although I changed my major to civil engineering, I always retained a fondness for forests. And combining all of this, when my wife and I moved out to Estacada in 1991, we also raised fish from trout and steelhead to salmon. And here we are delivering trout to a local U-catch operation. And if you look closely, you can see the trout with their heads pointed upstream within the 6-inch hose there, just as they would instinctively do in a river. I thought that was kind of interesting in that photo. The other thing we did was we co-founded the Friends of the Eagle Creek Watershed to generate interest within our community about the beautiful area we live in, and to care for it and enjoy it for all it has to offer. And one aspect of this venture was to develop the Estacada Forestry and Natural History School, where children from our community could come out free of charge and explore nature with guides from such organizations as Oregon Trout, the U.S. Forest Service, and the Audubon Society of Portland. And we also do semi-annual litter pickups that continue on to this day. Our family designed and constructed a 4.4 kilowatt micro hydroelectric facility on our place to generate carbon-free electricity, which powers most of our needs. And no dams, just run of the river with a screened intake to keep small fish out, as shown in the left photo. Portland General Electric even came out to see how we did this, as the system was very economical to construct and it's very simple to operate. And so we also undertook this project to demonstrate to our kids the applicability of the science and math classes that they were taking in school, and that, you know, someday they could do something similar. And then lastly, we also have done some thinning at our place, as shown in these photos. Due to yarding limitations over our creek, we chose a skyline system to be able to yard the logs over the creek, and we retained a logger with that capability. And we planned the thinning for a sustainable yield and to maximize future aesthetics. Removed about 238,000 board feet of saw logs and about 259 tons of pulp. Other than the skyline corridors through the riparian area, we implemented a 80-foot no-cut buffer on either side of the creek. And we always try to practice sustainable forestry. So with that as a background, let's dig into our topic for today. And what we'll cover for today is basically for woodland owners, farmers, ranchers, any folks who live along a creek or river, and simply just the curious. And, you know, a natural question one might ask is, why do we do these restoration projects? And I think it could be encapsulated in this picture here. If you look at this photo, you can see two large logs framed on the left and right. And then the female salmon, or the hen, on her side, scouring the gravels in the creek to create her nest of red. and the male salmon just laying back waiting for her to finish up there. And this work where these logs were placed was done in the summer of 2020, which created a nice pool there in that particular spot and retained some native spawning gravels. And spawning by a coho pair amazingly began several months thereafter in November of 2020. And then we'll talk about culverts and why they can sometimes be a problem, engineered log jams, boulders and spawning gravels, side channels, salmon carcasses, trees, water quality and water temperatures, funding sources and costs where you can get some money to do this work on your place, references for further reading. And the examples again are drawn from our creek, which is known as Suter Creek. And in Oregon, it's defined as a medium type salmon steelhead bull trout stream, which is very common in our watershed in terms of size, which means that its annual mean flow is between 2 to 10 cubic feet per second. And ours is right close to about 10 cubic feet per second, or about 4,500 gallons a minute. But of course, it can, in the winter months, can go up to over 10 times that amount. All work of this kind requires the proper permits, of course, can only be done during approved times of the year. And it's often said that the level of restoration can often be greater than what it was to disturb the system. And I think in our case, that's indeed true. And why do you do these restoration projects? It's to keep our waters, I call it the 4 C's, cool, clean, connected, and complex, to produce a strong aquatic life biological response. And you can do that through several ways. And the first one is making sure you've got good fish passage. So if you look at this photo on the left, that's of 2 6-foot diameter culverts that Suter Creek passes through in the county road, our county road that goes over the top of it. And that photo was taken in 2014. And then in 2016, I wrote a grant to get some money from Portland General Electric to remove those culverts and replace it with the bridge. So I designed the bridge as a community service and had contractors pay for with this grant to install the bridge. So that's the photo you see in 2018. So prior to this work, only a 1 mile of stream was available to anadromere, or to salmon and steelhead. Beyond that, it was a complete barrier to juvenile salmonids and a substantial barrier to adult salmonids. So by taking out these culverts, it opened up an additional 5 miles of stream to anadromere. So it went from 1 mile of fish being able to swim through up to over 6 miles. And the second thing is to create complexity in your creeks. So now if you can imagine, this is a photo of taken just several months ago of some large wood we put in back in 2014. But prior to this, this was just a simplified reach. There was nothing in it. The creek was scoured down to bedrock. There were no gravels, no sands, no sediments, no nothing. And so what we did is we put this large wood in, and in a number of spots actually, but and historically, we did it because historically the quantity of wood in streams, as you can imagine, particularly in the Northwest, was much greater than it is today. So the biota of forested ecosystems evolved in and adapted to these features. And you can imagine that it provides ample cover for fish rearing. And to me, it goes beyond just the mere science of it. I think there's beauty in this. I mean, if you lay out these large wood structures to try to emulate nature, if you look at this closely, there's a lot of complex flow regimes of the water, and just the beauty of the large wood and whatnot. I don't know, I think it's really something special. And then the third thing that way we do this for is to enhance what they call hyporheic flows, which are merely a term to define the percolation of the flow of water through sand and gravel and sediments and other permeable soils underneath and beside the open stream bed. So you can imagine as the large wood forces water over, under, and around obstructions and into the gravel and the soil voids, creating pockets of downwelling and upwelling in the stream, the gravels and water storage within the stream banks as well. So, you know, a side benefit of this is that if you think about it, if you orient the logs properly, you can actually scour out portions of the stream bank. And if there's gravels in there, they can then be washed downstream and hopefully add to the spawning gravels that perhaps weren't there before. And of course, nature does this on her own too in a number of ways. And one way is the use of beavers. And contrary to myth, beaver dams are usually passable by most salmon and steelhead. And plus beavers create pools, ponds, and expand wetlands for salmonid rearing and enhance that hyporheic flow regime. And so we promote beavers and their habitat, and there's been a move afoot, particularly in Oregon and Washington, to expand beaver habitat because people are recognizing the importance of these mammals. In this picture I took back on the left side back in 2013 of about a 4-foot tall beaver dam. It was one of 5 on our place at the time. And then of course, beavers, they eat themselves out of house and home, and they move on and the dams degrade and fall apart. And then it takes a while for the riparian area to regrow, but it always does because typically the beavers don't kill those hardwoods. They're able to, as they coppice, they're able to regrow. And you can see here, we've got quite a dense shrubbery and small trees growing back, and the beavers are actively chewing down these trees, as you see in the photo on the right in March of 2022. Personally, I like the old Benny Beaver mascot there from OSU. He's quite a happy beaver, and that's what we try to promote at our place, are happy beavers. And if you like to read more about beavers, a good general read on that is Eager, The Surprising Secret Life of Beavers and Why They Matter there. That's a good book. I recommend it. And where can these types of projects take place? Well, if we look at that lower middle photo of Oregon, and then we blow it up on the left side there for Clackamas County, and you can see the amber color, that's the U.S. Forest Service's Mountain National Forest land primarily. And then if you see the 2 shades of green, the light green and the darker green, those correspond to small private woodland owners, and then the larger private landowners like Weyerhaeuser and Port Blakely and whatnot. And then I put a little red star in about where we are located for our property. And then I circle with the red ellipse there in the left photo, the area where any of this kind of work can take place. So it can take place on woodlands as well as agricultural lands and any other natural and working lands. And it's important to think about and consider, and can be integrated into your planning efforts, particularly if you're a farmer or something, to add or improve fences, add or improve wetlands, et cetera, because historically, most of Oregon's best coho habitat was in these lower elevation streams where we live, and they're facing increased pressure from development and whatnot. So I think it's incumbent upon us, whenever we have the opportunity, to try to do what we can. And if you look at the statistics on the right there, you can see how forest land constitutes about 80% of the total land area within Clackamas County. And of that, the federal government owns almost 2/3 of that, about 600,000 acres. But what's interesting is that small private woodlands owners own more than large private woodland owners, which is usually not the case in Oregon. Usually large private woodland owners own more. So us small private woodland owners have an opportunity here to really do a lot of good for the community and for the fish. And so the next thing that we've done is we've done quite a bit of tree canopy restoration. And I'll explain in a minute why that's important. And if you look at the photo on the left, taken in April of 2016, you can see how our area there was inundated quite heavily with invasive reed canary grass and blackberries. And then the photo in January of 2022, you can see how things have changed quite drastically just in a period of 6 years. And that was done through the Clackamas River Basin Council's Shade Our Streams program, which was funded by PGE. So at no cost to us, they planted over 5,700 native trees and shrubs from 17 species over a stream length of over 1,800 feet, which is about 1/3 of our property length. And back in 2016, and it was an amazing improvement, as you can see. And so this is just a small portion of what they did. And the reason why trees and tree canopies are important is multifold. It's all about water temperatures, bank stabilization, cover, future large wood, and nutrients for aquatic insects, such as what's coming from falling leaves, down wood, et cetera. So if you look at this graph, this is part of that water temperature study that I mentioned earlier. And this part of that study just focuses on the North Fork, Eagle Creek, and its tributaries. And we're one of the tributaries of the North Fork. So Cedar Creek flows into the North Fork. What are graphed here are basically 7-day rolling averages of the maximum daily water temperatures. And so you can imagine the water temperatures spike every day, right? As the sun comes up, the water heats up and then it gets cooler, and then it does that every day. And so what this does is it smooths it out. And if you look at the x-axis there, that's the weeks of the year last year, starting in June and extending through the end of September. Then the water temperature in degrees Celsius there on the horizontal or the vertical axis. And I have several red lines in there, the one that goes all the way across the page. And these are set by the Oregon's Department of Environmental Quality. You can see that the maximum temperature for salmonid rearing and migration is set at 18 degrees Celsius or about 64 degrees Fahrenheit. And then the temperature for maximum salmonid cold core habitat, including spawning, emergence, and adult holding, adult holding is 16 degrees Celsius or 61 degrees Fahrenheit. And then you also see there's two ranges shown there. There's the DEQ sublethal limit range on the far right, and that's defined as conditions that cause, let's say, decreased lack of metabolic energy for feeding and growth and things like that, and susceptibility to increased pathogens. And then the other limit there, the DEQ incipient lethal limit range, is for or defined as the breakdown of physiological regulations such as respiration and circulation. And then death to salmonids that will typically occur above 29 degrees Celsius. And so if we look at this graph, you can look at that bottom curve there, that green one, and that's the temperatures that were smooth from the most upstream logger up in the Mount Hood National Forest in the North Fork Eagle Creek. And you can see how those waters are plenty cool, no problem at all. And then if you go to the topmost green curve, the light cyan colored blue curve, sorry about that, which was it's only a partial curve because somebody found my sensor and threw it out of the water up onto the bank. But anyway, you can see what you can see there, how much the water temperatures increased over about 12 or 13 miles of creek length, about 10 degrees Celsius or almost 16 or 18 degrees Fahrenheit, somewhere in there. And then the other interesting thing is that if you look at the more bright sapphire blue colored curve kind of in the middle, that's our most downstream sensor in Cedar Creek. And it was cool. It had a couple of bumps in it that were above their ranges, but generally it was cool and considered not to be a problem. But even more interesting is that dark, almost black curve below it is the curve of our water temperatures upstream just by our eastern property line. And this one astounded me until I thought about it, realized that what that's representing is we found inadvertently, just by accident, a cold water source in our creek, whether due to an underground spring or underground flow from one source or another, that's keeping our waters cold. So it's important that we try to find these areas, statewide to help keep our waters as cool as possible. So the conclusions from this graph are that the waters exceed the thresholds for salmonids in the lower North Fork Eagle Creek, about the lower 4 miles, and lower Bear Creek during the summer months, but were not instantaneously lethal. And the cold water source, as I mentioned, was discovered in Cedar Creek. And the conclusion that one can reach from this is that we should try our best to increase tree canopies across the woodlands, farmlands, and any other areas where we can. There are areas of high concern. And there were, by the way, higher water temperatures recorded in the lower segments of Eagle, Deep, and Clear Creeks, some of which reached points of lethality for the fish. And if they were not able to reach cooler water, would have died. So a simple way to evaluate your stream's water quality is by doing a census of the aquatic insects or the macroinvertebrates that are in one's creek. You can certainly do a sophisticated chemical analysis too, but this is kind of a fun way of doing it and a way I like to do it just as a hobby. And if you look at the upper left-hand photo, you can see a neighbor of mine and I doing some sampling. He's holding basically a simple screening system we made. We just took some really fine window screen and took a couple of wood dowels and joined the window screen to that. And then I've got a rake and I'm raking the gravels into the screen. And then you take it out and you sort out the aquatic insects from everything else that's in there that you captured, and you go back to your house or wherever and you look at them through a stereoscope like we're doing and you try to identify them. And we're just simply amateurs. We're not experts by any means, but we probably found about 20 different orders of insects. That's about as sophisticated as we can identify. But several years back, the Clackamas River Basin Council retained an outfit called Cole Ecological to come out and sample 7 places around the entire Clackamas River Basin for aquatic macroinvertebrates. And the creek at our place was one of those 7 sampling sites. And it just so happened to be the most biologically diverse and of all the sample sites that they had sampled. They'd found over 67 individual taxa that were identified. As you can see, I took their information and constructed this pie chart so you can see the different orders of aquatic insects that we found. So when you start studying where these insects like to live, you find that they really love clean water, which was an affirmation that we got water at our place. And then, for those that like to learn more about this, a really good reference is that Streamkeeper's Field Guide. It's written at a high school or freshman year of college level, very readable, fun to read. You can learn lots of things to do to keep your stream healthy and learn more about it. Now, the next thing we're going to talk about is culverts. And culverts come in all different shapes and sizes, and they're just nothing more than just one way to convey water, typically under a road or something like that. And you can see here that culverts are available as galvanized iron, polyethylene, or concrete. And they come in all shapes, from round to squash to pipe arch to bottomless arch. They even come elliptical. It's just you leave it to your imagination to what can be made. And generally, culverts can be fine. They're a good solution to convey water. And if they're designed right and installed right, will operate for years, just great. But sometimes if that's not the case, you can get some problems that are a problem for fish. And so the top picture there shows a pictorial of a narrow culvert. If it's too narrow, the water flows too fast, and fish sometimes can't, particularly juvenile fish, can't swim up through that area. So that's a barrier. Or the culvert may be too wide, and so the creek effectively almost dries out or gets to the point where they aren't able to propel themselves against the water to move upstream. The next idea or problem could be that there's no pool below the base of the culvert or the drop area of the culvert to allow the fish to jump up into it. So that could be a potential barrier. Or if the culvert's up too high and doesn't allow the fish to, they can't jump high enough to get into it, particularly juveniles. And I've seen all forms of these problems looking at culverts in the past. So if you're concerned about a culvert function on your place, consider, if you live on forest lands, contact your local Department of Forestry Stewardship Forester. If you're on other lands, contact Clackamas Soil and Water Conservation District or the Clackamas River Basin Council, Department of Fish and Wildlife, or Clackamas County for additional guidance. And engineering assistance should be retained for difficult conditions. And sometimes a bridge crossing is a better alternative than a culvert if you can afford it. But just to give you an idea of how extensive the culvert problem is in the Clackamas River Basin, I downloaded this from the Department of Fish and Wildlife's website. And all these black dots denote partial or complete barriers to fish passage. To give you an idea just geographically what this represented here, if you look at that ellipse on the left side, that's Gladstone area. That's where the Clackamas flows into the Willamette. Then if you look at the middle ellipse there where Eagle Creek is, and then down below where Estacada is, and then a little farther upstream where Promontory Park is. And so all told, there might be about 30 river miles or so of Clackamas River shown and associated watershed. But anyway, all these black dots are a problem. And so as we were talking about previously, if you've got areas of warm water to the extent that the fish could be stressed or killed, if they can't find sources of cold water, if they're prevented from doing so by these culverts, then we've got a serious problem. Or if they can't get to areas that they need to spawn, could also be a serious problem. So that's why culverts are a big deal to try to address. Now, how does nature do large wood jams? And as you can see here from the three photos starting on the upper left and going in clockwise direction, I think one of the key takeaways from this is that, to me, large wood is like snowflakes. And they're all unique. There's no copy, they're all different from one another. And I like to take pictures of these things because they are pretty fascinating. And so what we do is we go backpacking or hiking in areas which haven't been disturbed by folks to see what does nature do when left to our own devices. And another key aspect of this is that a lot of times wood that lasts a long time in these creeks and rivers, one of the key components is that they're anchored by one or more large pieces of wood, say wood that is 4, 5, 6 or more feet in diameter, just a really large piece. And large wood like that could be there for 100 years or more. And when I was in college, if we look at this graph in the upper left, I got this report and was reading it back then, and it left an impression on me. I copied it for this presentation. And it shows you something here that's applicable to large wood, even though it was pertaining to wood debris on the ground. And that really in nature, Mother Nature works in terms of centuries. And so what we're trying to do is in perhaps a matter of years is what nature takes centuries to do. And if we look at this graph to explain a little bit of what is represented here, if you think of time zero as a time when after an extensive wildfire, let's say goes through an area and a forest is starting from scratch, and the trees come in really densely, and then they start to thin themselves out naturally as they compete from one another. And so then as those trees die, the ones that can't compete well enough, they add to the debris on the floor, on the forest floor. So you see that jump there where it says tree thinning. And then as the other trees start to grow and they drop their branches, they continue to add detritus to the forest floor. There might be a ground fire shown in stage 3 there, where the fire initially burns a bunch of that woody debris, but then it comes back because the trees that were burned also die. And then as the forest continues to evolve and the trees grow and die, it keeps adding more and more. And then there might be a windstorm, which may blow some trees down to give you a further spike in tree detritus on the forest floor. So you can imagine that a lot of these things are also going to land in the water. And so whether they just happen to, just by happenstance, just fall across the creek or land in the creek or land adjacent to the creek, or maybe land, fall, they're on a canyon and they fall down the canyon and slide down into the creek or roll into the creek. There's a lot of ways that the large wood can get there. Now, another question one might ask is, well, if you're going to put this stuff in the creek, how often should you do it? And I didn't know. And so I found this fascinating study done in 2003, where some folks at the University of Washington went out to the Olympic National Park, and inventoried all the different types of large wood they found in the Keats River basin. So they looked at all the tributaries as well as the main stem of the Keats River. And they show all these different dots you can see here. I'll explain a couple here in a little bit. But I drew a vertical red line there, which represents the drainage area of Cedar Creek. So if you look at that and the two ellipses there that I've drawn, if you look at the shaded area, those shaded squares that I say they're about maybe 6 per mile, those would be the valley jams. Those would be the ones that we just showed the picture of, those logs that fall directly across the creek, and you get these basically these classic log jams that help to slow up the water. So there's not many, maybe 6 per mile on average or something. Nothing magic here. This is just what these guys found. And then if you look at log steps or bankful bench jams, like I show in the photos at the left, those are denoted by the shaded triangles and those dashed lines, those bolded dashed lines there. And so log steps, you've probably seen those pretty commonly. And if they're not a passage barrier, are often a great way to retain gravels. And then similarly, if you look at the bankful bench jam, in this case, there's a few logs here. There's a really large tree that's probably about a 4-foot diameter Doug fir or so that just either fell across the creek and was rotated by heavy water or just happened to land in that direction. But anyway, it's a bankful bench jam. So you see these are fairly common, 50 to 110 per mile. So they're very common. But the other thing to note from this that I think is pretty interesting when you look at this graph is that the frequency of jams of whatever size, whatever shape, configuration, whatever, decrease as the drainage area gets larger. That you would, if you can imagine a straight line, it would be decreasing as you go from the upper left down to the lower right. And so what does that tell you? That means that the forest floor, the forest influence diminishes to some degree as the drainage area increases. So, fish like coho and steelhead, whitewater fish, they've evolved with these logs to help them retain gravels into rear and whatnot, whereas larger rivers like the Clackamas River and things like that, the effects of large wood are much more diminished. So if we look at engineered log jams that we've done at our place, if you look at the upper left-hand corner, that's a picture of a couple of trees, and you can see Cedar Creek here. It's just very bare, very simple, scoured down to bedrock, nothing to write home to mom about at all. Very, very boring. And then if you look at the lower left-hand picture, after I had a contractor put logs in the creek, you can see our sun there for scale, and you can see the large log with the root wad that was placed. That's almost a 3-foot diameter tree. We've donated all the logs for this project from our place. And then in the foreground, you can see a couple of other logs, about an 18-incher and a 24-incher. And then if you look at the photo in the lower right, which I took just a couple months ago, you can see how much the stream has changed. Now, we added some boulders for additional complexity, as you can see, but it's a completely different creek now. I mean, there's deep pools, there's gravels, there's sediments. There is just more natural what you would expect. So it's amazing how things can change in just a period of 6 years. So what stream characteristics and large wood configurations provide for a good project? Well, an excellent book or pamphlet to read, you can get it online, published by various state agencies here in Oregon, is there in the middle. It's the Guide to the Placement of Wood, Boulders, and Gravels for Habitat Restoration. And I extracted this graph on the left side, and you can tell in an instant, if you know the range of slopes of your creek, as shown on the horizontal axis, and then the bank full width, or how wide your creek is when in high water, say once every year or two, when we might have a high water, like this past year we had some high water. And you graph that intersection of those two areas, you can see where you are. If you look at that red ellipse that I show, that's about where the majority of our projects take place. And so we're in either an ideal condition for habitat improvement or pretty close within acceptable conditions. And if you either own a very steep gradient creek, or if it's very wide, for example, getting close to a river, those are things that you definitely want to have a fisheries biologist consult with and engineers to make sure that whatever it is you do is done properly, because the amount of hydraulic force and whatnot can be pretty substantial. And I won't go through this text, but just to show you a couple of key points here is that the thing to keep in mind is that this is pretty easy to do, and a lot of folks use this, is that it's the alphabet configurations of large wood jams. So think about various letters and how you can arrange logs. And what's the key here is that you're interlocking these logs so that if they're going to move most likely as an assembly. And you can combine these different letters depending on how many logs you have to work with. And as you can see here, you can use simple X's to Z's and whatnot. Just it leaves it up to your imagination and what it is you have to work with. And generally, you want to have logs that are at least 1.5 to 2 times the length of your creek, or excuse me, the width of your creek. And you want to try to place wood between standing trees, as I'll show shortly. And simple patterns can be formed as shown here. You generally want to use at least between 3 to 7 logs in any particular log jam. So here's some photos of some work on our place. And if you interlock logs within the jam into adjacent bankside trees. So the upper left-hand photo shows our stream restoration biologist, Dave Stewart here. And you can see there's a couple of Z patterns he's laying in here with these logs, and the contractor's got his track hoe with a choker cable, and they're putting the logs in. And a proper attention to detail is essential here. You want to get these logs to try to work together. And then the bottom photo recognizes how you can put a log in and how it's pinned between 2 trees so that it acts like a cantilever beam of sorts. And so there's no way that log is going to move until it rots away. And so by doing this, you can allow the jam to move vertically in response to the high and low waters, because wood is buoyant to a certain extent, even when it's waterlogged to a certain degree. But it should move little laterally downstream if it can all be avoided. And you shouldn't need to use steel restraints. Some folks use steel cables or spikes. Well, if you do it with the proper size creeks and the proper orientation, the proper attention to detail, you shouldn't need any of that. You should be able to enjoy a fairly natural, large woody debris structure. And there's some other considerations to think about. Landowners are exempt from liability on lands under ODF jurisdiction, Department of Forestry jurisdiction, if large wood causes damage. Consider donating logs from your own property if you have some. Prices can range from $500 to $1,000 per log delivered, depending upon the size and if a root wad is attached, so it's beneficial if you've got forest land to utilize logs from your own property. Logs may also be obtained from fire salvage operations, and they can be placed with ground-based machinery like a track hoe or a log loader or a helicopter. We've had projects done with that. Of course, they're going to be much more expensive, in the range of $8,000 to $15,000 an hour. And don't place all log jams at once unless they're separated fairly widely. You want to try to stagger placements if at all practicable to minimize potential bark beetle outbreaks, which could affect your adjacent live dug fir trees, which you wouldn't want to have happen. So other factors to consider when constructing engineered log jams, the size of the diameter of and the length of logs used will depend upon that bank full width of your creek. And the Department of Fish and Wildlife has guidelines for these. And creeks larger than about 30 feet wide should have log jams engineered by professionals that have done it before. Best fish habitat is formed with at least 3 to 7 logs per jam. Leaving limbs and branches increases stability and provides fish cover. And one must also consider wood rot. So, as a former structural engineer, and as anybody that deals with wood, you know that wood rots. And depending upon the species, the size, and the moisture content, it loses about 1% of its strength and density per year once the decay begins. And so you want to consider using as large diameters as possible, which therefore contain a low surface area to volume ratio and minimize that decay, because it's going to fail well before it reaches 1% strength. So you want to have enough there so it's going to last you a while. And the decay rate is usually slower than it is on land, because a lot of the insects and fungi that decay logs that we see on land will drown in the water. There are some that do live in water, but if the log is completely submerged, you've probably seen a lot of logs that have been there for 100 years that are just fine. But most logs aren't completely submerged. They're partially, or some of them completely exposed to the air and to the moisture, sporadic moisture, thus allowing decay to occur. So the best species for strength and longevity are Western red cedar, which is weaker than Doug fir but longer lasting, Douglas fir, then noble fir, and then Western hemlock, and then followed by hardwoods like alder and big leaf maple and that sort of thing. And I wouldn't recommend this kind of work within urban areas or near roadways, or where there's sensitive structures or residences or developments downstream, just kind of a common sense thing. And then properly sized, sited, and designed large wood jams could last 50 to 100 years or more. So with that, Glenn, do you want to take a break and have your next Q&A, and then we can resume?
Yeah, that's a good idea. If you do have any questions, now's the time, kind of a midpoint here. And I don't see any in the Q&A right now, but I thought of a couple. So while we see if anyone else has some, you showed that map of the culverts around, and that was mostly the Clackamas drainage, which is an awful lot of different problematic culverts around. So what kind of progress are we making, or what's the the program to try to fix those? What's going on in the basin with help from folks like you, other than folks like you? What's going on out there?
Good question. That map isn't updated. I found a couple of mistakes in it, but even if it's 90% right, it's still a problem. And so you can see that they are fairly extensive, but there are resources out there. We were fortunate that we got some grants. You can write grants to have culverts removed. There's money available. There's some programs that I would suggest contacting the Clackamas River Basin Council, or the Oregon Department of Fish and Wildlife to see what programs are available. I'll be talking a little bit about the new private forest accord in a little bit, which if you are doing logging on your land, there'll be funding available on your property and charged to you for those kind of things. So there's a variety of different sources, but I would say as a good central clearinghouse, start with the Clackamas River Basin Council or Department of Fish and Wildlife.
And do you know in general, like how much of that kind of work's been going on? I mean, I recall when I worked with the watershed councils on the North Coast, every year there was, a good number of projects that involved culvert replacements. And so is that activity still going on as far as, funding through the Watershed Council from Oregon Watershed Enhancement Board and other sources? What do you hear about that?
Yes, there is still funding available to do that. Normally for Oregon Watershed Enhancement Board, usually it's a small grant program you go through for about, I think, which are capped at around $10,000 or $15,000. You can do larger ones like those 2 6-foot diameter culverts that we had replaced with the bridge. That was about a $300,000 project. So it just depends on the size of the project and you know, what grants are available. These programs become available. Some of them are available. They come on board, you know, daily, and you just don't. It's hard to keep up with them. So it's good to contact those clearinghouses. But
Yeah.
to give you another example, those 2 culverts that we had in Cedar Creek, when I asked the Department of Transportation in Clackamas County, where were we in this getting these? Because it was clearly a barrier. They said, "Oh, you're about number 800," you know, and at the rate that they were replacing culverts, it wouldn't have been in my lifetime, you know. So you have to sometimes go out and seek other sources of funding when they're just not available.
Yeah, I know that active forest landowners, especially the larger landowners, you know, anytime they want to develop their road across a creek or, you know, access some of their land, that's always the opportunity, and also perhaps the requirement that they upgrade their stream crossings to improve fish passage. So kind of the larger landscape, I've been amazed at how much that's happening, that those culverts are being replaced and the roads are being fixed up to drain properly and improve water quality and that kind of thing. So I know it's really active out there in the woods. Well, I don't see any new questions come up. So with that, I think if you want to move on to rocks and boulders and gravel, what else one can do to enhance habitat? Go ahead.
I'll stop my video again so I don't get jaggedy. That's, like I say, it's the thing with living out here in the middle of the nowhere. You know, it's beautiful, but we have primitive technology. And by the way, Glenn, it's snowing blizzard conditions out here, so hopefully we won't have an outage. Very bizarre.
Yeah, your voice has been slowing down from time to time, but we're still getting most of it.
Hey, Glenn, we just did get a question arrive from Wes in our Q&A box about a resource, perhaps.
Oh, okay, great. So there's a question for you, David. Is there a book or a resource that you recommend for building your own hydropower resources?
Oh, well, if you bear with me a minute, I will go find it. That's a good question.
When you ask David a question like that, he's got references. He's going to find the answer.
So this is a book. It's called the Micro Hydro Design Manual, and it's written by Adam Harvey. You can get it on the internet. And this was very helpful to me. You know, again, it'll require some engineering, so you may most likely have to retain somebody familiar with civil engineering, electrical engineering, mechanical engineering. Luckily, we pretty much had all that in-house in our family, so we were good there. But this is an excellent book that teaches you everything that you need to know, and I would highly recommend that one.
All right, thank you, David.
You bet. Let's see, let me stop the video here.
Okay,
back to this. And so the next topic we'll talk about is boulders. And, you know, boulders may seem boring, but, you know, boulders are pretty cool, really. And if you look at the lower, or the picture on the left side, there, back in 2014, we put boulders in our creek. You can see me there on the top photo with a skid steer we'd rented, and we were moving boulders around. And our son in that lower photo, or the left side photo in the background, so he's about 100 feet away or so. But you see the number of boulders we put in there. And boulders are important in areas where large wood debris isn't feasible, or you can even complement large wood debris with boulders. But in this case, we utilized boulders because large wood just wasn't practicable here. So we selected boulders, and this is a good rule of thumb, at least twice the size. They call it D200 for twice the size of the largest boulders observed in the stream reach to minimize movement. So if you see a big boulder, get one twice the size, and that way you're pretty much rest assured it won't move very far. So, you know, not real scientific, but that works. And you want to arrange them in constellations or groups of 3 or more to enhance upstream sediment and gravel deposition. So what that means is that you can see in this photo that we've grouped them in such a way that as gravels are moving downstream, they'll be collected by those boulders, and that'll be sources of potential salmon or steelhead reds. And then again, place boulders where typically you'd find them. You wouldn't put them in a floodplain where they'd be covered up by silt, for example, but in bedrock dominated reaches like you see here, or where large wood jams are not practicable, then they're a perfect solution. So if you look at the photo on the right, taken from the same vantage point, just 8 years later, how beautiful it looks. The moss is growing on the boulders. There's lots of nice water. There's plenty of gravels behind them now. So it was a good solution here. And on our place, we've added over 200 boulders. And so now we're going to talk about gravels. So why are gravels important? And it's basically where salmon make their nests or their redds. So if you look, you can put all the large wood and boulders in that you want, but if you don't have a good source of gravels, whether it's natural or augmented by humans, they need a nest to build, put their eggs in. So you gotta have gravels. And so if you look at the photo on the left, it's a picture of me and one of the steelhead redds we had on our place back in the fall of 2020. And you can see the extent of the area that I show on the red ellipse that a salmon, in this case, modifies. The female salmon will move that kind of gravel in that pile. Like you see how it's much cleaner than the gravel around it. So she's taken gravel that had algae growing on it and whatnot, and scoured it with her tail fin and her other fins and created this nice pile of clean gravels for her nest. And then she creates that little pit like you see in the figure at the right. And then if you look again at the picture at the left, you'll see the yellow ellipse, and that's the probable location where she laid her eggs. Now, bear in mind, the creek the water is flowing, so the eggs are going to be moving, and the male has to simultaneously fertilize the eggs as she's releasing them. But generally, that's about where they are, and then she'll immediately cover the eggs with gravel. And if you look at this diagram, I like this old diagram from the 50s, back when they used to use artwork to demonstrate scientific stuff. You see the female laying on her side there, flipping her tail to excavate the cavity. And for coho salmon, what I've observed is usually those cavities are about 4 to 6 inches deep. And for winter steelhead, but for Chinook, they're about twice as deep. And one thing I thought was interesting about this diagram is that they didn't show the hyperrheic flows. Now, they may not have been known back in the 50s, or they may have thought about them. They just didn't bother to put them in the diagram. But today we recognize that those hyperrheic flows are, again, those waters that flow between the interstices of the gravel is very important, because that's what helps to oxygenate those eggs. So I drew that in there with that red arrow. Now, there's various ways to place gravels. Let me just back up a minute. I think I might have. No, I'm right. Sorry about that. So there are various ways to place gravels. If you look in the upper left-hand corner, you can do it just simply with a wheelbarrow, dumping gravels into the creek if you don't have, and all these locations that you see pictures of are because we didn't have access with a truck. I mean, if we had access with a truck, that's what we would have done, but these places could be hundreds of feet away from any road. And then the lower left, that's my wife there and our son operating the mini loader, dumping gravels in the creek. The two middle photos show a cable system we developed and put in to raise a hopper we built just out of some scrap steel, and then the tractor in the background would load the hopper with gravel, and then with another tractor would control the speed of that hopper down to where I was, you see in the bottom there, opening a trap door that we put in the hopper to let the gravels fall into the water. So that's a good way of, in this case, we had to move gravels over 300 feet from where this hopper was, where the tractor is. So that worked out really well. And then in the upper right, there's my wife again with a couple of friends using a flume we built that we would take apart and reassemble to move to different places to move the gravel. And the gravel costs about $350 for 11 cubic yards. So it's not too expensive, about for one truckload. And I suggest placing pads about 6 inches thick or about 12 inches thick for Chinook by at least 50 feet square for potential red. And place these pads at the toes of pools and upstream of and within large wood debris and boulder constellations to help retain the gravels. Now you have to place these during the low, what they call a foul wag, which I think is a Scandinavian term meaning a low point in the water. So you want to create a little channel with a shovel or a boot or something, just so that until the higher waters come back, the little fish, the little fry that are still in the creek can move from one place to another. Now, obviously, these gravels will move significantly in high water. And once the high water comes up, the foul wag is irrelevant. But until that time, you want to have that fall wag, and just recognize that where you place gravels may not be where they ultimately wind up. I mean, we've had some gravel locations that have been there for years. It just so happened they're retained behind some nice large wood or boulders, but others have moved, maybe 100 feet. Now for gravel sizing, I didn't know how big to, what size gravel do you order, And so I read some reports on it, but they were pretty sporadic and weren't really focusing on the fish that I was interested in, the coho and the steelhead. And so what I decided to do was doing my own experiment. So a friend of mine who's a geotechnical engineer has that picture of me. He's got a mechanical agitator with those sifters. And so each one is a brass disc that has screens of various sizes. And you put the gravel, you dump the gravel in at the top a little bit at a time, and then you shake the heck out of it. And then it gets segregated. Then you weigh each of those segregations for different gravel sizes, then you can graph it. And the thing I think the key takeaway from this is how closely these two individual reds, what I did was I went to 2 reds after the eggs had hatched and the fry had swam away. And so it was safe to do so. I went in and I gathered about 55 pounds of gravels from each of these old reds. And then I did this analysis, and you can see how closely the 2 individual coho salmon, these were reds 500 feet apart, so it wasn't the same salmon utilizing or making multiple reds, were. And so that gave me confidence that I was going to order the right size gravels. So I went to our local rock quarry and ordered drain rock, and you look at the picture in the upper left with the tape measure, you can see the different size gravels that I ordered. And then you order them by the various weight distributions that I show in that graph. And that way it told me, just to maximize, to be economical about it, make good use of the money, what the chances are to get the best gravels. So we've added over 150 tons of gravels at our place. And another thing that we've done is we've added side channels. So side channels are nothing more than just a channel off to the side of your creek. And that's a good place for refuge for the fish. And what you want to do is fairly simple. You just want to set an inlet up a little higher than your regular creek is, the main stem of your creek, so that the water doesn't flow in there. And low flow, you don't want to dry up your main stem of your creek and be a problem. So you raise up the side channel a little higher, or you, like I say, provide a little rear or something. And then when the high water comes, you can the water will overtop that and do what it needs to do. And you can also place large wood in that side channel, like I show. You also slope the side channel to drain a little bit toward to where it comes back and joins the creek downstream. So this is a picture of the side channel just after it was constructed in August of 2014. Here's a picture I took just a couple months ago showing the same place. And you can see how the side channel is working really well. It's full of water, and it's a nice place for the fish to hang out and not feel stressed because they've got a flood going at them. And it's also now an active northwestern salamander and red-legged frog egg-laying area, which we've seen a lot of egg clusters. So that's something that wasn't there before. And if you look closely to the previous picture in the upper right, you can see a log in the distant background on the ground with a lot of moss growing on it right by that white arrow. Well, if you look at the photo on the left, that's the same log, just on the butt end of the log. And we used to have some root wad attached to it, but that kind of scoured away over the years. So we've been adding root wads to it. Just to act like a little control valve so we can adjust the water in that side channel, the level as appropriate as needed, make sure there's always water in there in the fall, winter, and spring. Now, where are good places to enhance fish habitat? Generally, wherever there's a lack of cover for fish and or lack of hydraulic complexity, but there are excellent places to focus on. And they're known as areas of high intrinsic potential, which are spots based upon flow, slope, and channel constraint, which are inherent properties of the watershed at that location. You have nothing to do with that, are particularly well suited for salmon and juvenile rearing. And they vary by species. And these have been identified by the Oregon Department of Fish and Wildlife. So if you look at the map at the left, that's the areas that you see the kind of greenish lines that there are more chances more often than not where the coho would like to hang out and spawn and rear. And then the steelhead, which like a little steeper gradients, they like more riffle type situations. That's also been mapped. You can kind of see they're not always the same. And I showed our area in those 2 ellipses where we live. Unfortunately, we own enough of our creek that it contains both high intrinsic potential for both coho and steelhead. So once I knew that, I said, well, I'm in on whatever we need to do, because this this will help guarantee that we will get some good response from the fish. And one of the first papers on proposing this idea was by some folks named Burnett and Reeves and others in 2007. I think there's a quote here that's particularly apt where it basically says the widespread recovery of coho salmon is unlikely unless habitat can be improved in high intrinsic potential reaches on private lands. And I firmly believe that just based on the fact that the coho historically have lived in the flatter areas of our watershed in particular. So on your next logging project, consider a couple of things. Before I get into that, I just want to define some things for folks that may not be familiar with this. There is a term called the riparian management area, and that's an arbitrary area just defined in rule, the Oregon Forest Practices Act, that can vary from 20 feet to 100 feet, depending on a variety of situations, where you are limited in your logging that you can do. And so when and where practicable, select times of the year to minimize soil compaction with ground-based equipment and avoid building roads within or near the riparian areas. You want to check your road for drainage to minimize runoff and sedimentation. Consider exceeding limitations for the basal area that's left in the RMA. So, even though you're entitled to take some trees out in there, consider just leaving a few more in there. If it's a hardwood dominated RMA, consider thinning some. You don't need to remove them all, of course, because hardwoods are important, but just do a small conversion block to add conifers like western red cedar, hemlock, and Douglas fir for diversity. But also you need the larger trees in there for two reasons. Primarily, one is those conifers will grow much taller than the hardwoods, and so they'll help to provide more shade for this high water temperature problem that exists and will only be exacerbated with climate change. But secondly, that will allow those trees to fall into the creek to provide that more long-lived large wood debris, which is so important, which we just talked about. So consider adding conifers if there aren't many in or alongside your creek. Exceeding limitations for leaving all understory vegetation within 10 feet and within trees within 20 feet. In other words, consider increasing these buffer widths from here to there. Just recently, there's been a newly legislated private forest accord, an unprecedented agreement between the environmental community and the logging community that was legislated into law earlier this year. So it's brand new. And when formalized into rule at the end of this year, we'll also revise these requirements, and as well as culvert and forest road requirements. And so the private forest accord is shown with, that's a very voluminous document. It's around 300 pages, shown with the beaver and the salmon on the cover. But then the Oregon Small Woodlands Association took that information and digested it or condensed it down for just small woodland owners, because a lot of those requirements don't apply to folks like us. And that's an excellent document that's there, that's noted by the private forest accord from the Oregon Small Woodlands Association. So I would suggest getting a hold of those documents if you plan to do any logging on your property, because the requirements are going to become more stringent. We also place salmon carcasses in the creek on our place. So this provides, why would you do this? Play with a bunch of dead salmon. Well, it provides vital marine derived nutrients, mainly nitrogen compounds for fry, aquatic insects, terrestrial mammals, birds, and adjacent trees. And so I annually place about 40 along the stream, not many, about 40 over a stream length of about 4,000 feet. So if you can look at how I do that there, I take a carcass in the lower lower right-hand photo, and I shove a stick through its gill and then out through its mouth, and then I jam it in the large wood to help hold it there. And the bottom photo shows the 4 recycle bins that I take to our Eagle Creek National Fish Hatchery to get the salmon carcasses. So it's appropriate that they come in, that I use my recycle bins. And so there's about 40 there that we then place in the creek. And the photo in the upper left, this wasn't a carcass, at least that I placed. This just happened to be a bear had predated upon a live salmon and drug it up onto this large piece of wood. Log here, bit off its head to get at the brain because it likes to eat the brain, and left it up there for other scavengers. And then this other photo in the lower left was fascinating to me, so I took a picture of it. It shows a picture of a salmon carcass just completely inundated with caddis larvae. And I've never seen so many caddis larvae scavenging on a carcass before, so I had to take a picture. There's literally hundreds, if not thousands of them. It's all those little things look like twigs. So it was just phenomenal how much these salmon carcasses are utilized by life, not only animals, but trees. I mean, the trees that are close to the creek will also assimilate the nitrogen compounds from the carcasses into them. And that's been shown by numerous studies that that's very important. Just to kind of, as we wrap this program up, we also do miscellaneous riparian enhancements. We've constructed raptor and great horned owl platforms, you see on the left. We've built owl, duck, and bird boxes as shown in the middle. And then we've also created wildlife snags through tree girdling. You see me there girdling a large Douglas fir. We don't do many of these, just enough just to keep enough snags in production because you don't want to create a wildfire hazard. But most small woodland owners do a pretty good job of keeping tree mortality down. And you know, I think it's 20% of the bird species in Western Oregon depend on tree snags, either for food or for nesting. So it's important that we try to accommodate that to the extent that we can. So potential funding sources, consult to answer that question, to help answer that question that was asked earlier. Consult your local watershed council, as I mentioned, your soil and water conservation district, or Department of Forestry, Stewardship Forester, Department of Fish and Wildlife, as I mentioned, Department of Agriculture, the National Resource Conservation Service Office, if you have one nearby. They have technical assistance, grant programs, tax incentives, cost shares, et cetera. There's new programs being created every day, and I can't keep up with them. So it's best to just contact those folks to get the straight skinny. So in summary then, what we want to try to do is address the freshwater portion of a fish, a salmon or steelhead's life cycle. And so that begins with them migrating upstream. To give you an example, this is a waterfall in our creek. It's a 6-foot waterfall just downstream of our home. And you can see the coho jumping upstream for scale. So that's a pretty good sized coho. So I took that picture in fall of 2020, and they jump so fast, and they move so fast, they're blurry even with this photo. And then they move up to a good spot. This is the same photo I showed earlier where they're spawning. And then hopefully some of those eggs will hatch and the fry will rear up to fingerlings like we show here before they bolt out to the ocean and live out their oceanic life cycle. So this was the population nearby that red that I show you there to the right. So landowners, while working with the appropriate state and county offices and nonprofit organizations, can seek funding to restore streams and riparian areas within their properties. Many of these projects can be done with just a good amount of common sense and working with the right agencies. These folks want you to succeed, really. I've always worked with some great professionals. For those areas with sparse or no tree canopies, implement a tree planting program. Increased water temperatures are becoming a major concern. Also, trees provide a source of future in-stream large wood, as I mentioned. So remember, you know, the old adage, the best time to plant a tree was 20 years ago, and of course, right now. So if you don't do it, it never gets done. And tinker with caution, work with the river or your creek, and know your limits. You know, seek design guidance as required. I mean, nature is always going to be testing your efforts, so you don't want to waste a bunch of money because you didn't dot all your I's and cross your T's. So what changes have we observed? You know, and this is just a graph. There's no cause and effect here. I don't want to infer anything, but this is just observation that to me gives me hope. But again, you know, it's not scientific by any means. But if you look at this graph of a couple of things I want to explain here, that vertical red line shows when we began fish habitat restoration work in the summer of 2014. And if you look to the left of that line, those are the counts done by the Oregon Department of Fish and Wildlife of salmon themselves. So they're not the reds, but the salmon. So you can see there weren't many, hardly any counted in our creek in those days. And, you know, salmon, you know, even in that 2009 one, if we're seeing 26 salmon, if it takes a male and a female, of course, a male can fertilize multiple females, but let's say, you know, maybe 10 or 13 could have been reds, or they could have been coming up our creek and saying, hey, this isn't the place. They turned around and went back and went someplace else. So we don't really know how many reds they built. But then starting in 2014, or starting just before 2014, they started to count reds. But since it's done on a more random basis, they didn't, between 2009 and 2014, they didn't do any surveys. But starting in 2014, coincidentally, and luckily for us, they did. And you can see the response. Well, I don't want to say response again. But anyway, you can see how many coho reds have been found on our place each of those years. And 2020 was our gangbuster year where we had 73 coho reds over the course of 2 miles, of course, on other people's property as well. So that was just phenomenal. I mean, it was just unsurpassed. And the other thing that's important too is that the pool riffle ratio is increased, and I'll explain what that is in a minute, from virtually nothing, 0.05 to about 1/10, to up to 3/10 to over half. So what that means is, let's say, to keep the arithmetic simple, you have a stream that's 100 feet long. So in that 100 feet, you may have 5 or 10 feet of it as pools, the rest of it's riffles. Well, fish really need pools. They need lots of pools. And of course, steelhead, when they're younger, like the riffles, but they also seek out pools. So the key is to the large wood and the boulders create these pools as well as places to cover and whatnot. Well, the work that we did with putting all this large wood in has increased that pool riffle ratio, by a factor of 10 about in some places. So it's incredible. So over a length of 100 feet, then let's say we've got between 30 to 60 feet of pooling, which is extremely advantageous for the fish. So to tie this all together, to keep our waters cool, clean, connected, and complex, what you want to do is, if you have high intrinsic potential, it's icing on the cake if you have it. If not, that's fine. You can still do this kind of work, but that just tells you you're in a perfect spot. If you have good water quality, which we know we did, as I showed, and good water flow, which I showed you we did, and suitable water temperatures, which I also showed you we did, boom, you're halfway there. If you have good habitat access, which I showed you we didn't until we did that work. We removed those culverts, and that opened up the stream to our fish. So now we've got good fish passage. And now if you have good physical habitat in the terms of large wood, gravels, low sediments, blah, and et cetera, which, parts of which we didn't have, right? That's why we added all the wood and the boulders and the gravels. Putting that all together, your Venn diagram says you should be having some excellent responses to your fish. So if you can get all these things, but even if you don't have the high intrinsic potential, if you can get those other things, you could really make a big difference to your place. And so to sum it up for the Clackamas River Basin, for that part of our basin, including the tributary watersheds like Eagle Creek and Clear Creek, below Promontory Park, which is 7 miles upstream of Estacada, I believe it's up to all of us to try and do our part to address these challenges, since this is mainly all private land, as that map I showed you indicated. State and local governments just simply can't do it all. So for further reading, reference lists will be posted with this link. I've got dozens of references on there. But if you had to break it down into the why and the how, of course, the why, what gets you jazzed about getting up in the morning. The Sand County Almanac by Aldo Leopold has always been one of my favorites. I was first to encountered that in high school. I had a high school teacher that suggested that we read it, and I love that book, and I read it every couple of years. The Fish in the Forest is another good book that should be brought out every fall, so you can read about the salmon. It's an excellent book. And the How, the Oregon's Forest Practices Laws, an excellent publication put together by the Oregon Forest Resources Institute, explains a lot of the minutiae of those laws, also pertaining to riparian areas. And then, as I mentioned, the Guide to Placement of Wood and Boulders and Gravel. If you want to learn more, I've got a number of videos I put together about the work on our place, over 20,000 views. And that's my YouTube channel there, I guess. But anyway, the videos are, range from just 1.5 minutes up to 24 minutes, depending on how deep into the details you want to get. But I think you could learn something from those. And then what's next on my docket? I would like to engage in the North Fork Eagle Creek project. It's something we're currently raising money for. And if we do get the money, it would begin next year in 2023. It involves all those agencies noted in the upper right-hand corner. And to my knowledge, would be the largest watershed restoration project in terms of extent, in terms of miles addressed within the entire Clackamas River Basin, if not the state of Oregon. So I hope to really, I think we could make some very substantial difference in a very special place around the area in which we live. We've got a lot of folks that are interested in wanting to help on this. So I hope it comes to fruition. Right now, it's about almost an $800,000 project, of which we've raised over $258,000 in in-kind contributions. So we're on our way. And that's it. That's all I have. That's a picture of one of our gates. And there's my wife, Mary Ann. So with that, I'll open it up to any questions.
All right. Thank you, David. I thought I knew some of your story, but this really is the comprehensive A to Z version that is amazing how much you could pack into it. Of course, it's your lifetime of work, as you showed us from the beginning. So looking for Q&A. So add your questions to the Q&A box. I'll ask a question to start out. What kind of strikes you? You must have learned a lot along the way, although you tried to plan everything out and do your homework before so that it comes out right the first time. But what are the kinds of things that you learned, about how to succeed in fish habitat restoration?
That's a good question, because I'm always learning something. I mean, I watch these webinars and I hang out with with forest scientists and biologists. I'm always picking tidbits from them, and you try to sift through all the information you get to come to the things that make the most sense. But I think what probably helped the most is just having that drive to want to do something with your place, to be a good land steward. And then it helps to have a civil engineering background, because so much of this is regarding soils and water and things like that you learn with that as a background, and the things that you did as your profession. So it helps to make sure that at least that you minimize your mistakes. I mean, everybody makes mistakes, and I've learned from my mistakes, and I think that it's just a combination of all those things, and a lot of reading, like articles. I've got a book right here that this is my journal Bible right here. So it's stuff that I've accumulated since college, and I've got stuff in here that's over 40 years old that I consider to be excellent references to stuff that I've just got a month ago. And so I mean, science is a learning process, right? So they're learning new things, and so I would say it's just a combination of all those things, and then you try it out. Does it work? If it works, great. If you see fish, then that's the ultimate test. But if it falls apart, if you don't see any fish, then you go, well, maybe I better try something else.
Well, there was a comment which was just thanks for an inspiring presentation. So appreciate that comment, Bruce. You talked about or you showed the count of the reds that have gone up quite a bit, and especially 2020. Now, I think you told me that you walked that 2 miles and counted them yourself. Is that right? Or was that ODFW data?
That one was my data, and I was pretty conservative. There were others that I counted, but I wasn't sure, because sometimes the fish will create, for lack of a better word, I call them a test red. They'll start to excavate, and for whatever reason they go, this isn't quite right. So then they'll move on to something else. I've seen them do that. And so if I saw small reds, maybe this big, I discounted those, or I didn't count those. But ones that were clearly reds, or ones that I had seen the fish, because I would walk the creek multiple times, and you could see that's the beauty about coho, is that a female coho seems like a very caring mother. I mean, she will lay her eggs and she will stay there until she dies. And so you can see where the reds are a lot of times, because the fish are right there, and so they're pretty obvious. And then they'll die, and then their carcasses will float down. So there's a lot of ways you can see the fish and count the reds. And so that particular year, that was me counting them. There could have, like I say, there could have been more, but those were a safe bet. Yeah.
Right. I'm going to start the next poll. We've got a final poll here. Let's see, where do I get that? Just a little wrap-up poll before you leave in the audience here. If you have a chance to answer the questions about the presentation and what you thought of it, and then I'll just leave that running. So if you would, go ahead and do that. And then to see if there's any other questions that come in. Okay, I don't see any more in the Q&A. You said how many feet of the stream are on your 83 acres? How much of the stream?
It's over 4,000. It's like 4,100 or something like that. So there's a lot of places. And as I was mentioning to you yesterday, it varies from steeper gradient, where you might find steelhead predominantly, to flatter gradient, where you see the coho. And the forest and the steeper gradient is about 100 years old, whereas in the flatter area it ranges from seedlings up to 60 years old. So it's a nice variety to experiment with. And I would just encourage folks that if you know other folks that live on creeks that you think might be interested in this, feel free to give them the link when you get it, because the whole point, I think, of all this is for all of us to work together to help solve this problem, because it is a problem. Lack of fish habitat.
And then in all that improvement that you did in your different stream reaches, what's the most salmon that you've seen now since since you started that just on your property?
Well, I mean, you could see dozens of adults, dozens. It's really it's an inspiring sight, to see them. But then the last summer, last summer when we were doing the gravel placement project, I mean, there were hundreds of fingerlings, fry swimming everywhere. I mean, just from that spawning, magnificent spawning season of the fall of 2020. So basically what happens is that, let's take fall of 2020 as a benchmark. So they spawn in fall of 2020, the eggs will hatch, say January, February of 2021. So last year, and then they'll stay around the nest for about maybe a month or so until they get all buttoned up and they're ready to venture out. And then they'll hang out until about March or April of this year, assuming the habitat's right. If they have good habitat where they got lots to eat and the water's cold, there's no reason for them to move. And so they'll stay here till they're ready to smolt, and then they'll bolt out and then move down to the ocean, which they'll do fairly quickly. But some, if the water's warm or the habitat isn't good, they'll swim downstream or upstream till they find a place that they can live. It's just kind of, that's just the way it is. And so for our case, though, we saw the pre-smolt salmon from that were spawned in fall of 2020 just leaving a month or two ago. You could not, obviously you don't see them all, but you see little groups of them moving downstream. So that told me that it's a good spot. They like it here.
Yeah, well, I think that would show up in that pool to riffle, because the pools are often a good place for the fish to hang out that has more, structure and cooler water at the bottom and things like that. And of course, that's a huge part of this enhancement is the habitat for the rearing, for the young, as well as, of course, the gravels and such for the spawning. So I had the pleasure of serving on some of the monitoring of a lot of the ODFW grants on the North Coast. And so we would look at about 50 projects every year and then get out and see what the results were. And it's just amazing to me what the efforts of people like you and working with the agencies, just how much of a difference it makes in a hurry when you add the fish passage back and then you start adding the gravel, and the people don't realize that a scoured bedrock stream is not a natural thing in the Northwest. Just amazing the results in terms of the fish response and the whole the macroinvertebrates in the whole ecosystem. So I'm really glad to see that. There's a question here. Is there a link or a website specific to the North Fork Eagle Creek Fish Habitat Restoration Project that you mentioned? Is there any information on that out there on the web yet?
Probably what I would suggest is a two-step approach. One is I created a website called the Friends of the Eagle Creek Watershed. And if you just Google Friends of the Eagle Creek Watershed, it should come up. And that there's some beginning information that kind of help people get situated with the why and the how. But then if there's more specific information that's wanted on this particular project, just give them my email address and I can contact them and talk with them, because we're currently in the process of writing grants to, like I say, to get this project funded. But there's no reason why we can't extend it up even more. We have a landowner just upstream of this he's an awesome landowner, and his family, the family's an awesome landowner. And I think that they would be interested in becoming involved in something like this. So we could extend it into the private sector. This North Fork Eagle Creek project right now is just on Clackamas County land at Eagle Fern Park, through Portland General Electric property, and then through the Bureau of Land Management. So it's just basically on institutional or governmental property, but we could certainly extend it on up if we got even more funding, and that would even be more cool. Hey, so that's what I'd like to do.
About half of the folks in our audience didn't have a fish stream on their property or weren't involved so much. But if people are interested, how can folks get involved or contribute even if they don't have it on their property?
Good question. So if you're in Oregon, your local watershed basin councils, there should be one, I think mostly in every part of the state. you just Google watershed basin councils, and you should find one in your area. They're always looking for volunteers to do tree planting, litter cleanup, things like that, throwing the carcass into the water. So that's a great avenue. If you're outside of Oregon, then I would suggest contacting your local or your state Department of Natural Resources, or if you've got a local like Trout Unlimited. Trout Unlimited is an excellent group to focus on and get in contact with. They do restoration work. In fact, our large water temperature project that I'm doing, we got a bunch of our sensors donated to us from the local chapter here of Trout Unlimited, so they appreciate the importance of good salmon and steelhead habitat, and they need to know where the cold water is. So there's groups like this that I think, there's a lot of, you just need to find the ones that are really active and that you want to be a part of.
All right, thank you. Well, that's a great inspiration, a good example. So we're going to keep learning a lot more, and I'm glad you've got that YouTube channel, and encourage everyone to visit that, because it's really fascinating to see, it in action, and also to watch the fish when they come back. With that, we're at just 4:30, a little past, and I'd say last call for questions for David.
Yeah, like I say, if anybody thinks of any questions, sometimes it's hard to think of a question right at the spot, but feel free to, email Glenn if that's okay, or if you have my email address, just email me, and I want to help out wherever I can. So, I'm perfectly happy to sit down with anybody. We can drink a beer, whatever you want, talk about this kind of stuff.
Well, yeah, and I should point out, actually, just last weekend, David, you hosted the Healthy Streams workshop that you do on your property, and you do that every year, right?
Yeah, except for the past 2 years of COVID, but prior to that, the 2 or 3 years prior to that, we did. Yeah, and we had a good turnout. We spent 3 hours. We walked through the place. You can actually, see, touch, smell, the large wood and the gravel. You can actually see it in action. And we were there when we were there last weekend. We actually found a steelhead red. So.
Oh, excellent. All right.
Yeah, so people could see a red if they hadn't seen one before.
Yep. So if you can't visit David's place, there's other good rivers and streams near you, and just encourage you to go out and see what's happening in your neck of the woods. So with that, I want to thank Dan Stark in the background for doing the co-hosting, putting all the links up in the chat. And then David, thank you again. Thank Julie Woodward and Oregon Forest Resource Institute. And thank you all for coming to the Tree School Online. Stay tuned for the future when we come up with another plan for Tree School and other education opportunities. So with that, I'll call it a day. Thanks, everyone.
Thank you, everybody.
Okay, goodbye.